Good day, good people. Let's jump right into our example. We are trying to figure out over what intervals is the function increasing and concave down. So this goes into some of our curve sketching techniques. So the first part, if we want to find something that's increasing or decreasing at interval, what we would do, we would find at least the first derivative. So the first derivative of this, well, that means we bring the 4 to the front. So that'd be 4x subtracted by 1, 4x cubed over 4 minus 16 times 3 is 48. So that's 48x squared divided by 3 plus 2 times 77 is going to give me 154 over x divided by 2 minus 98. And then the derivative of just a constant is 0. But we can actually reduce this just a little more. So we can say that this would be x cubed minus 16x squared plus 77x minus, and this was supposed to be a 98, minus 98. Okay, so that is our first derivative. By taking this first derivative, we are also finding our critical points. So for the critical points, what we would need to do is we would need to factor we would need to factor x cubed minus 16x squared plus 77x minus 98. Now, this is slightly different where technically it's a cubic, so we would at least try to see what we can factor out of the first two and then see what we can factor out of the second two. However, second two terms. However, if we look at this, there's nothing that they can really be factored out, and we would end up with the same parentheses or binomials. So the next piece that we would need to look at, since that wouldn't work, is in factoring trinomials such as this, when we have the first term just being x cubed, we would really look at our last and our second term. All right, so our last term is 98. I would need to know what really multiplies to be negative 98, but add up to be negative 16. So again, I want to see what's going to multiply to be negative 98, but I also want to think about what those terms would be that would add, or factors would be that would add up to be a negative 16. So 98 is really 49 times 2, which really is 7 times, 7 times 7 times 2. So technically, 7 times 7, and if I made them all negative, 7 times 7 times negative 2 will still give me a negative 98. And if I added a negative 7 plus negative 7 plus a negative 2, that would actually give me a negative 16. So I would write this as a factor of, because there's two x minus 7s, I'm sorry, there's two negative 7s, I would write this as x minus 7 squared times x minus 2. Now, the reason why, again, I knew I needed 3 of these terms is because, remember, my exponent here is a cube. So that means I needed 3 binomials to make sure that I factored it out totally perfectly. Now that I have this factored out, I can go ahead and finish finding my critical points, where I can take x minus 7 equals to 0 and say x equals to 7. And then I can say x minus 2 equals to 0, and I can say x equals to 2. So these are my two critical points, but I'm going to save these critical points for later because I am looking for not only my increasing, but I'm also looking for my concave down. So I'm going to do everything at the same time. So my next one is I need to find my second derivative because concavity comes with the second derivative. So we would do, ooh, that's a bad color. We would do the second derivative. And now let's go back and remember what my first derivative was. It was x cubed minus 16x squared plus 77x minus 98. So we want to take the derivative from this point here. So this would give us 3x squared minus 32x plus 77. Now we come to the next point again where if we're looking for our concavity, we also have to get our PI, which is our point of inflection. So to get that point of inflection, that means we have to factor or set our second derivative equal to 0 and solve. So how can I get 3x squared minus 32x plus 77? How can I factor that to solve? Well, we would look at, what multiplies to be the first times the last, right? We remember I do the slide and divide. So the first times the last will give me a 231. So what multiplies to be 231 but adds up to be negative 32? Remember, it needs to add up to be this middle number. What multiplies to be 231 but adds up to be 32? So we would say that would be 21 and 11. And if we make them both negative, then that would add up to be a negative 32. So we could write this as, excuse me, x minus 21 and x minus 11. But we can't forget that we need to divide by this leading coefficient of 3. So we'll divide it by 3. Now, we can take x minus 21 divided by 3 equals to 0. And we can take this x minus 11 over 3 and set it equal to 0. So this will give me x equals to 7 and x equals to a positive 11 over 3. Now I have 4 points. I have 2 critical points and I have 2 points of inflections. Please note that our point of inflection of x equals to 7 and our critical point of x equals to 7 happen to be the same. So now that when I get ready to start my sign chart, I don't need to repeat that x value of x equals to 7. So let's jump right into it. We would need a sign chart. But before we get a sign chart, I kind of write out my numbers on a number line so we can see. So we have positive 2. We have 11 over 3, which is roughly 3.7. So that will be 11 over 3 here. And then we have 7. And again, we don't have to write 7 twice. I want to select points when we are trying to do our sign chart. We want to select points around our critical and point of inflection points, right? So to the left of 2 would be 1. You can pick any point. I'm just picking the points best for me, right? Between 2 and 3 point, what did I say? 3.6 or 3.7? Well, we could say 3, right? On in between 3.7 and 7, we can say 4, right? And then on the outside of the 7, we can say 8. So when we are creating our sign chart, we need to use these values of 1, 3, 4, and 8. These are going to be our test points. All right. So let's test our points. Not only are we going to test them in your first derivative, but you're also going to test them in your second derivative. So the test points, let's do one. So let's hypothetically say we're going to test number 1. So our first derivative, if you recall, is x minus 7 squared, and it's going to also be x minus 2, right? That was from our first derivative. So if we plug in positive 1, well, let's see what we end up having. So that's 1 minus 7 squared times 1 minus 2. So that would be a positive times a negative. So this will give us a negative, right? Then let's use our second derivative as well. Our second derivative was x minus 7 times 3x minus 11. All right. So if we look at that, that is, again, 1 minus 7 times 3 times 1 minus 11. So that's a negative, times another negative. So this is going to give us a positive. So out of all of this, I can say for the space around 1 is going to be decreasing because of this first one. So this is going to be your decrease and your or increase, right? And this is going to be your concavity. All right. So this means that it is going to be decreasing, and since it is a positive here for the concavity, it's going to be concave up. All right. So let's try another one. Our next number that we had on our test chart was positive 3. So for 3, we'll do the same thing. So that would be 3 minus 7 squared times 3 minus 2. So this will be a positive times a positive, which gives us a positive. And then if we do 3 minus 7 times 3 times 3 minus 11, well, that is a negative times a negative, which gives us a positive. So in this case, this will be increasing, all right, and it would be concave up. All right, so the next piece, we want to try our test point of 4. So if we look at it, we can use 4. I'm going to create this a little better. So this will be 4 minus 7 squared times 4 minus 2. So that will give us a positive times a positive, which is a positive. All right. Then we have 4 minus 7 times 3 times 4 minus 11. So this will give us a negative times a positive, which is a negative. So this means that this is going to be increasing, increasing, and it is going to be concave down. All right. Then our last test point that we need to use is 8, according to our test points. So if I use 8, then this will be 8 minus 7 squared times 8 minus 2. So this will be a positive times another positive. So that gives us a positive. Then we have 8 minus 7 times 3 times 4 minus, 3 times 8 minus 11. So this will give us a positive times a positive, which is a positive. So this is increasing and concave up. All right. So based on this, on our original question asked us if over what intervals is it increasing and concave down. So if we look back at our test chart, it's increasing and concave down here at this part of 4, right? So if we look at the space that is around 4, that means between 11 over 3 and 7, it is going to be that description. So it is increasing and concave down. From 11/3 to 7. All right, and that concludes our video.